Hello, everybody. Welcome to the Math Friday Math Happy Hour. And today we're gonna be talking about the exam to review. So we're about that time. We're gonna test for our second exam. And let me open my review. Usually, it might be better if I just show the questions. So I'm gonna go through a series of questions that cover most of the topics that you saw after the first exam, starting with logic. And so I'm gonna go through everything. In the instructions, it says to write the statement in symbolic form. And I have the following uh, statements. Remember that a statement in mathematics is represented by usually the letters P, Q, R, S, T, so lowercase letters. And in this example, my first let me double check, just every time I start I'm always freaking out that everything's correct. Okay, yes. Also, if you cannot hear me, please let me know. So the first statement, which is labeled P, starts with it represents the statement Taylor Swift is a singer, and then Q represents Taylor Swift is not a songwriter, and R, Taylor Swift is an actress. And our job at this point, usually when we have a statement in mathematics, you're supposed to determine if it's true or, well, that's how you know if it is a statement, if it's true or false, not both. So in this case, it doesn't really matter. What we're going to do is we're going to use them to write these compound statements. We would call this kind of like simple or single statements. And then we have longer ones that we can represent in symbols using the variables P, Q, and R. So starting with number one, we have Taylor Swift is a singer and an actress. So here, usually what I emphasize my students is to start by looking for the preposition. So we have a preposition and then on the other side, we have the or. We also have parentheses. So remember that parentheses represent groupings. So we're supposed to, I'm sorry, we're looking for commas which represent parentheses. Okay, so now let me see if I can use a different color to start with the first one. It says Taylor Swift is a singer. This statement, exactly how it is represented with the letter P. Then we use the symbol for and, which we also call it the conjunction of two statements. And then when you put it in this way, another statement would be like Taylor Swift is an actress, which is actually the last one. So this is actually R. Even though the Taylor Swift part only happens once, by using the conjunction, it's still referring to Taylor Swift. So that's the whole R, that Taylor Swift is an actress. Now, because of the comma, this is where we put parentheses, and then we do an or symbol, which now it's like a V. She is not a songwriter. Well, that's exactly what Q represents. Taylor Swift is not a songwriter, so this part is actually Q. So statement number one, which we call a compound statement because it's formed from three and then using symbols and parentheses, is represented in this way. So it'll be parentheses, P and R, close parentheses, or Q at the very end. Now let's do example number two. So same thing, when you start, maybe a good idea to start would be start by looking for that comma. That's always a good idea. And then notice besides the comma, something that stands out is the prepositions. So we have the or in here. We actually have then and if. And remember that the then and if is actually the conditional statement. So both of these two together create a single statement. And the conditional is represented with an arrow. So we have that arrow towards the right. And we have something on the left, so we kind of gotta fill in the gaps. Let me see if I can choose another color. So we have a gap on the what goes on the left and what goes on the right. On the left, we actually call it the antecedent, and then on the right, we call it the consequent. So the conditional statement usually tells you something that needs to happen before, and as a result, then you have like a conclusion. Okay, so now I'm gonna fill in those gaps. So it says if Taylor Swift is not a singer, so if she's not a singer, when I go and look at my initial variables, P says that she is a singer. So here, because I have the not preposition, is the opposite of P, which we represent with the letter, with the wiggle line. So this is not P. So by putting that line, I'm saying the opposite of what P means. So Taylor Swift is not a singer. And then if then, this and this, those two prepositions are represented with this arrow. Oh, well, actually I'm missing, before I move to the then, I need to put the or. So or, not an actress. Again, if I go to the variables, R means that she is an actress. So the opposite of this would be not R, close parentheses. And then on the right, it says then she is a songwriter. So notice that Q actually says that she is not a songwriter, but then on the compound statement, I have the opposite, that she is. So I'm gonna do the opposite of Q, which is not Q. So example number 2, if Taylor Swift is not a singer or not an actress, then she is a songwriter. It's represented with these symbols. Now let me erase this part just not to make it confusing. So the final answer should be parentheses, not P or not R, arrow, not Q. Now usually these not doesn't really need the parentheses, but you can leave them in there, because in logic we also have like an order, a hierarchy of operations. It is a good idea to put them there, but usually even if without parentheses, it would make sense that all of this is together and then you have, but it just makes it more clear. So let's just put it. I'm gonna go back and retract. It's better just to add the parentheses so we know that you have to apply. It's kind of like PEMDAS. You have to figure out the value of the parentheses before you can move on to the next part. Okay, so the next one would be number 3. So for number 3, it says, it is not the case that if Taylor Swift is a singer, then she is a songwriter. So even though we don't have the if, this is, well, we actually do have it, huh? It is not the case. So let me start by highlighting that sentence. It is not the case that, and then we have the if and then. The if and then prepositions, they are represented with arrow that goes to the right. And then I'm gonna ignore the first part, it is not the case, and I'll continue by saying Taylor Swift is a singer. So I'm gonna go back to my variables. That is actually P, Taylor Swift is a singer. Let me see if I can put them like halfway where we can see. So here, that's P. This part is P. I'll highlight it again. And then after the preposition, we have then, which follows the consequent. That's what goes on the right of the arrow. She is a songwriter. That's the opposite of Q. Remember that in this example, Q was represented as Taylor Swift is not a songwriter. So the opposite of this is actually not Q. And now, if I didn't have that initial statement or that initial part, it is not the case, then it would just be the symbols like if Taylor Swift is a singer, then she is a songwriter. And so this, it is not the case, is telling you like the opposite. Like another way of saying this is by saying it is it is false. So it is false that this is true. So basically, you're trying to say the opposite of what I already wrote. So to do that, you're going to enclose all of this in parentheses and you put that wiggle line. So usually that when a sentence starts like that, like it is not the case or it is false, that everything else that you're saying it's is wrong. So you put it by putting the wiggle line, which is the negation, and then everything else in parentheses. Okay, so that was an example of how to translate English statements or English sentences into symbolic form. In the next example, which is questions 4 and 5, now I'm going to do it the opposite way. I'm going to use the letters P, Q, and R. And now they're actually exactly the same ones that I had before. Now I'm going to put into words these symbolic statements. So the first one, notice how I have P, and then this is the symbol or. So I'm going to write down whatever P says. So I could say Taylor Swift is a singer. That's P. Or, that V symbol is the or. And then R. And then I could just make a contraction. And since I already put Taylor Swift, I could just say or an actress. An actress. So the whole thing says Taylor Swift is a singer or an actress. And then because I have parentheses, that's where we put comma. So those parentheses that group letters in English, they represent sentences that are separated with a comma, that are grouped with a comma. And then at the end, I would put Q. Well, don't forget the symbol. So that symbol is the and whatever Q is. And since we already know like the subject of this statement, I could just say she is not a songwriter. So comma, and then since I cannot continue in my right, I'm just gonna put it below. She is not a songwriter. So all of those symbols represent this statement or this compound sentence, which says Taylor Swift is a singer or an actress, and she's not a songwriter. So moving on to the next example, this is the one that has the conditional. I know there's a conditional because I see the error right there. So this is an if and then. So because that error is there, I'm going to start with if, and then I'll put whatever P is, and then and then the rest of it. So P is Taylor Swift is a singer. So I'm going to start by writing that. If Taylor Swift is a singer, then, and notice that on the right, I actually have a bunch of statements that are separated with a comma. So I'm going to separate this by a comma. Usually when you put the comma, you're supposed to put it right before the then preposition. We actually had an example like that before. Look, let me show you. That was example number 2, where that's where the comma is. So I'm going to put the comma there. So if Taylor Swift is a singer, comma, then, and then the next part, which is Q and not R. So Q means that she's not a songwriter, and the opposite of R would be she and not an actress. So I'm gonna put all that together. Then she is not a songwriter. And because I have that symbol is the and preposition, not a not an actress and not an actress. If you want, you could put the whole thing. Like you could again put the pronoun in there and say she's not a songwriter and she's not an actress. Okay, so moving on to the next one. It says number 6. So now I'm finished with the whole translating statements into English and symbolic form. So now I'm gonna do the construct a truth table for the given statement. And for this part, so I always start by looking at how many variables I have. And notice that the two different letters are actually P and Q. Even though here I have the negation of P, like not P, it's still the letter P. So I only need a table that has two variables. So I would start with the two variables and then, so each one in each column, and then everything else, the whole compound statement goes on the right. Just like in math, these variables are gonna be kind of like my entry points. And when we talked about truth tables, I always recommend always to start the same way. So you could do like truth, 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 false, false, truth, and false, false. It's not like you cannot change the order in which you put them, like the order of the rows. Let me highlight the rows of the table. So that's one row, second row, third row, and then fourth row. But what definitely you shouldn't miss is that you need to have all 4 different combinations where you have like T and T, T and F, F and T, and FF. That's very important that you have all of the different combinations of the truth table. Maybe your instructor might tell you like, hey, always put the same order. And if you don't put it in that order, it's not considered correct. So make sure that you ask your instructor like, hey, do I need exactly? I always tell my students do it that way, only because when you don't do it that way, you end up missing some of those combinations. Okay, so next, the easiest way to do these tables is by writing the entire statement again. So you put like P and parentheses, not P, arrow, Q. I always tell my students like space them out because we're gonna put the truth values under the letters and under the symbols, and it's just easier if you do it that way. So next, to do the table, I like to start using PEMDAS. So I do a following PEMDAS. So I should either start either inside the parentheses and either on the left or on the right with the not P or the Q. It doesn't matter which one you start with. I'm gonna start with Q just because since there's nothing on Q, all I need to do is copy the exact values that Q has. So for example, if Q starts, if I look at the column that has Q, there's true, false, true, false. You can follow exactly that pattern. So true, false, true, false. Because it is exactly the same statement. If you already input these values, then it has exactly the same values. And a good practice is always to label your columns on the bottom, like where did you start it so that you can track your steps. Number 2, you go on the left with the not P. And because it has that wiggle line, which is the opposite of P, I'm gonna change the values. So if you go back and look at P, we have true, and then true, false, and false. So I'm gonna do it opposite. So this will be false, false, true, and true. So because of that line is the opposite values that P has. So that was my column number 2. Then I move on to the arrow. So the arrow is the conditional statement. And at this point, a good idea would be to have the truth tables. Now, I don't have it in here, but let me kind of like, let me see if I can add it very small here on a different color, perhaps. So And I mentioned this before as well, that when you're doing your truth tables, you probably should ask your instructor, like, will I have access to all of the tables? Because otherwise you need to memorize them. So if you have P and Q, and then the conditional, which is that arrow, you can have the same, and then so the table for P and Q looks pretty much the same, where you have like true, 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 false, false, true, and false, false. And the conditional statement, it is only false in the second one when you start with a true and you conclude a false. So this is false. It's going to be true in all of the other cases. So basically what I'm looking is for that combination in that order. If I have a true on the left and a false on the right, then my answer will be false. In all of the other cases, it's going to be true. In all of the other cases, it's going to be true. So to find the answer, I'm going to look from left to right, starting on 2. So I'm going to start here and then look at whatever it's on the right. And notice that I have false true, so the value for this is going to be true. And then I have false false, then this is true. I have true and true, so this is true, and true and false. This is actually that line that I highlighted. This is the only time when you get a false. So you put a false here. And this is number 3. And basically, if you notice, I'm doing this kind of like as if you were adding, as if you were doing like an operation between two numbers. So the result of the entire parenthesis is actually the values that I have in column 3. And I'm going to leave it there because it's going to be used to find the final answer of the whole thing. So now I move to the left of the parentheses and notice that I have the and preposition, and I also have the P. So I'm going to fill out the values for P. This is true, true, false, and false. I copy exactly the same values that P has. That was my number 4 column. And so the final answer of the entire statement or the entire table, the final result of this table will be under that symbol, which is the and. So now, just like I did a little table for P, for the conditional statement, and all of these tables you should have been provided with. They are in the book. If you don't have it on your notes, do not worry. Just go back and look at the book and you'll find them in there. And so if you have two statements connected with an and, actually the and is only true when both of them are true. So that's actually the first row. And all of the other one, the other 3 combinations, if there's at least one false, it makes the entire statement false. So in this case, we're looking for that pattern, only true when both of them are true. If I have at least one false, then it's gonna make it false at the end. So to find this result, the last column, number 5, I'm gonna look at each row in the columns 4 and 3, because remember that 3 is the result of the parentheses. And if I start on the first row, let me see if I can use, so if I start with this and this, I see that I have 2 truths, then I put a true here under the symbol. And then for the next row, I see true and true, so this is going to be true as well. And then I have false on the left. Well, it doesn't matter what I have on the right. As long as there's one false, it makes the statement false. And same thing, I have another false, so this is false. So these columns are the final values of the entire table. So true, true, false, false. Okay, so that was this example. Let's do the next one, number 7. It says determine if the statements are equivalent. To have equivalent statements, what you would do is you do the truth tables and then you compare their final values. If their final values have exactly the same letters in the same order, in the same rows, Like if it's exactly the same sequence, true, true, false, false, then that implies that both the statements are equivalent. So basically you're checking that the statements have the same truth values. Okay, so let's do this one. Again, this is a good practice to do tables. The only perhaps difference or um, the idea is that you're doing two different truth tables and then comparing them. Now you could put them all both in a single long table, but I'll do the two tables. So you have P and then Q. There's also only two variables here, P and Q. And then the first one has not and then parentheses P or Q, all of this. And so to start with my first table, I'm gonna do the same sequence of values, true, 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 false, false, true, and false, false. So this is always, whenever you have two variables, it's always 4 rows because each variable has two possibilities, true or false. So if you multiply 2 times 2, that gives you a total of 4 different combinations, 4 different possibilities. All right. So now I go and do P or Q. Now, if you didn't have the parentheses and if you didn't have um, the, the negation symbol, then this would be just the table. Again, there is already a table that gives you those values, just like how I construct these tables, like the smaller tables that I'm always using to find my answers. They're in the book. These are kind of like the initial tables for everybody. So let me tell you, just using exactly the same one as before. If you had an or, then the values, when you have the or, basically the whole statement is true if at least one of them is true. It's like saying like either this one or the other one has to be true, or both. So if both of them are true, it's going to be true. If at least one of them is true, only when both of them are false, you're going to get a false. So you only get a false when both of them are false on the left. So to do this, if you want to, you could copy the values again, true, 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 false, false, true, and then false, false. This could be your columns 1 and 2, and then in the middle you put the value of the or, which we mentioned is true as long as there's one true, and only when both of them are false is false. So this is my number 3. And finally, to do the negation next, you would now you do the opposite of 3. So since the answer for the parentheses is in column 3, and then I have the negation symbol, which is the opposite, then all I do is switch the values in red. So in the first row, I have a true, so then the negation will be false. Another true, so the negation is false. Now another true, the negation is false, and then false at the end, the negation is true. So this column number 4 has the final values of the entire table, of the entire statement. Now I go ahead and do another table for the second statement for this one. So as I mentioned it's like starting over, do a brand new table with P and Q, and then you write down the entire symbols. Always space them out a little bit because we're gonna put letters so that you have enough space. When you don't space them out, when you don't space out the letters, like scatter the letters on that, so that you have enough. Otherwise, you'll have them like all very close together, that it's hard to check the table and read the values from the two. It's much more easier to make mistakes if everything is crunched together. Okay, so when you're doing a table, you always start the same way, same sequence. false, false at the end. And then now here, I'm gonna just go ahead and do the negations. So when you're doing symbols, usually this, if there's no parentheses, then the negations have to be done. You know, just how we follow PEMDAS, you start with parentheses. That's the first thing. Then you do exponents. So similarly, when you're doing statements, you start with parentheses. There's no parentheses in this part. And then you do negations. That's the next level. That's the order. So I'm going to do those negations, which is basically the opposite of the letters. So to do negation P, I'm going to do the opposite of the sequence that P has. Since P has true, true, false, false, then the opposite would be false, false, true, true. And then I go on Q and I do the same thing. False, true, which is the opposite of what Q has. And now I do the and symbol. So between these two, between 1 and 2. So my final answer is going to be on 3, on column 3. And if you guys recall, the and preposition is true only when both of the letters are true. So if I look here on the left and on the right, both of them are false. So this is false. Then I have false, true. So that's false because both of them need to be true. True, false, I have at least one false, so that creates false. And only at the very end, I have true and true. Well, that makes the and true. And so my answer for this statement is in column 3. Well, if you check them, it's actually not too bad to see them. Notice that they have exactly the same values in the same rows. Both of them are false in row 1. Both of them are false in rows 2 and 3. And both of them are true in the last row. So these two statements have exactly the same truth values. So that means they are equivalent. When you have different statements, sometimes there will be equivalent, sometimes they're not. But in this case, these two are equivalent. So the way that we write them, we don't say that they're equal. Instead, we use this symbol. So negation P or Q, it's equivalent by using 3 lines to not P and not Q. So by using those 3 lines, we're saying that even though they use different prepositions and different connectors, in the end, they convey the same truth values, the same meaning of the statement. All right, so that was number 7. Now, number 8, something that we also talked about was the converse, the inverse, and the contrapositive of the statements. And in symbols, so if you have a statement, these are all conditional statements. And then the conditional statement, the basic one is P implies Q. If P happens, then Q happens. Well, the converse and the inverse and the contrapositive work as in this manner. So the converse is actually when you flip the order. So this would be Q implies P. So in symbols, that's how you put it. The inverse is actually when you negate them, when you put negation. So it would be like not P implies not Q. So originally you have P arrow Q. So you keep the same letters in the same order, but then you add the negation symbol. And finally, the contrapositive is like a combination of the converse and the inverse. So you're gonna flip the letters, you're gonna switch the places of Q and P, and you're also gonna negate them. So it'll be like not Q, so Q goes first, and then negation implies not P. Okay, so going back to the instructions, it says write the converse, inverse, and contrapositive of the following statement. Now, when it says write, it kind of implies that you gotta write it in English. So the answer to this exercise has to be a sentence that has English. But to do that, let's identify. So the if and then, well, actually, there's not a then, but we have a comma separating. So all of this is P, and then all of this is, well, actually, including the we, is Q. So if she does not return soon, then, or even if you don't have the then, you can just put comma, which is a pause. Then the next means everything that goes after the comma, this is the consequent. We will not be able to attend the party. So to write the converse, just switch the order of those ones. So you could start with if we so we will not be able to attend the party. So you could even change the tense of the sentence. So right now it's kind of like in future, we will not be able to attend the party. So you could change it to if we do not, or if we are not able to attend the party. Comma, and then P says she does not return soon, then we could say if we are not able to attend the party, we could even say she didn't return soon, or she did not return soon. Did not return soon. So I usually say, like, you might want to write it in a way that kind of like makes sense, like the typical uh, sentence structure. That's what I kind of like. If you notice in the book or even in your homework, you've noticed that often they change the tense. But if you find that confusing, you can just write it exactly with the same tense. So you could have written, if we will not be able to attend the party, then she does not return soon. So if you wanted to keep it in the same tense, that's fine. It basically conveys the same meaning. Huh? If we are not able to attend the party, she did not return soon. Just kind of like when you change the tense, it kind of like it's more it makes more sense. It's how usually you would say it. You know? All right, moving on to the inverse. So the inverse, now you're gonna keep the same order of the letters, so the same order of the sentences or statements, but you're gonna negate them. Now, don't forget that they all need to have the if, at least the if and then comma, if not both. So now I'm gonna put both. I'll put the if and then before I'm gonna put the then later on. So P, the sentence P is supposed to be she does not return soon, or it is she does not return soon. So because I'm following these symbols, not P implies not Q, then I'm going to change the opposite of that. If P is she does not return soon, then P, the opposite is she did. She do return soon. So if she returns soon, then what happened? Well, the opposite of if Q is we will not be able to attend the party, then we will be able to attend the party. That's the opposite. Then we will be able to attend the party. The party. So the whole sentence, this statement, this whole compound statement, the inverse statement that you can create is by negating the statements P and Q, and now it looks like this. If she returns soon, then we will be able to attend the party. Okay, so that was the inverse. Now let's do the contrapositive. So the contrapositive, you gotta switch and negate. So I'm gonna start with Q. Remember that Q is the second one usually. So let me delete that and then just highlight it. So Q is this part. And it says we will not be able to attend the party. So the negation is we will be able to attend the party. So I'm going to start with the if. Don't forget that if we are able to attend the party, comma, and now I look at P, which is everything before, and I'm gonna negate it as well. So P says she does not return soon, then she returns soon. So if we were able to attend the party, then she returned soon. Again, to me, it just makes more sense to put it in past. But if you, and then this one I did not even, but if you just want to leave it with the same tense, like you could have just said, we will be able to attend, if we will be able to attend the party, then she returns soon. Well, actually, you're supposed to change it anyway. But you can leave it in present. Okay, so that was my final answer for the contrapositive. If we are able to attend the party, then she returns soon. Which again, it makes sense. One last comment before I move on to the next example. Just as a reminder, the original statement is always equivalent to the contrapositive. So if you kind of like say them out loud, they convey the same meaning. If she does not return soon, we will not be able to attend the party. It's equivalent to saying, if we are able to attend the party, then she returns soon. I know sometimes when you read them, it doesn't kind of like seem like it, but they are equivalent. So we talked about equivalent before. We did an example. So equivalent is when they have exactly the same truth values. So if you were to do the truth table for the original sentence and also for the contrapositive, you will notice that they are equivalent. Okay, so the next one is now translate the argument into symbolic form, then determine whether the argument is valid or invalid. So here you can use your own letters. I usually like to use, you could still stick with P and Q, or you could change them like you must eat well. So maybe W for well, or that's the symbol, or you will not be healthy. So here, a good idea is to kind of like, what does each one represent? So you could start by saying you must eat well. So that's W, you must eat well, or you eat well. And then often students, because they see the not, they want to write like negation, which you could if you want to. So then the original, if you have H represents you are healthy, then the negation would be exactly that, you will not be healthy. So negation H. And then next is I eat well, so that would be W. And then remember that this line indicates that the conclusion of these two is below the line. Therefore, which is represented with 3 dots, therefore I am healthy, which is therefore H. So this whole argument, now the argument is always divided into sentences. Let me write it below again. So the first and the first part of this should be the first sentence, you must eat well. So we said this was W, or not healthy, not H. So that's number 1. Number 2 was I eat well, which is W. And then the conclusion, therefore, which is these 3 dots in a triangular shape, I am healthy, so the conclusion is H. So this is how we write it. This argument is written in symbolic form in this way. Now, to determine whether the argument is valid or invalid, you could do a truth table. And I actually have it. I do have some PowerPoints for this, but I didn't like how the PowerPoints came out, so I was doing everything myself. But let me see, because doing the truth table might take me longer. Let me see if I can find it. That way I don't have to redo it again. Um, I forgot what question is. Let me look at my question. Yeah, question number 9. So this is the correct one. If you notice here, they're using exactly P and Q. Instead of changing the letters, you could always. So in my example, I did W or not H. In the PowerPoint is P or not Q. But then if you do it like that, just remember to define. So write down what P means and what Q means. That way, that's not confusing. And so each one of those lines is called a premise. So you have premise 1, premise 2, and then the last line is the conclusion. So this is how it looks in symbolic form. Now, unfortunately, there is no truth table here. So I'll come back and do it or let me see if I could do it very, very quickly. So to do the truth table, let me erase this so that I can give me enough space. So again, I had two variables, W and H, and then you have, you're supposed to have a table for each one of your premises. So it was W or not H, that was premise 1. And then premise 2 is simply I eat well, which is W. And then you even put your conclusion at the end, which is I am healthy, that's the H. And so you do the truth table. This is not such a long truth table. Now there's many ways that you can actually do this. The way that I like to do it is by putting truth, false, false, truth, and false, false. Well, actually, that's not what I wanted to tell you. What I wanted to tell you is the way that I determine if it's a valid or invalid argument is by creating the values for each one of them, and then anytime that the premises, so this is premise 1 and premise 2, anytime that the premises are true, the conclusion has to be true as well. So I'm looking for a specific rows. Let me show you. So start by doing the values of W. So that would be true, true, false, and then false. And then notice that I have negation H. So change the values, false, true, false, true. And then let me put my sequence of columns. So I started here and then number 2. Now I'm gonna go in the middle and do the AND. Remember that the AND is only true when, well, actually it's not an AND, it's an OR. It's only true when, it's always, as long as one of them is true, it's only false when both of them are false. So I have a true here, so that's true. I have both true, so this is true. I have both false, so this is false. And I have at least one true, so this is true. Now I go on to premise 2. Since premise 2 and the conclusion is just the letters, so I copy the same values, true, true, false, false, and then for H would be like true, false, true, false. Okay, I did the table. So that was 3, 4, and 5. Next, I'm looking for the rows, only those rows. So I'm gonna go row by row. There's only 4. Remember that rows are the horizontal ones. I'm looking for the rows where both premises are true. So I have here true and true. The next one as well, I have true and true. And then the next rows actually do not qualify, so I'll put them in red. So this one and this one, since both of them are false, the second one does not qualify either, since the second one is false. So I'm only looking for those rows where the premises are both true, or all of, if I had more premises, I need all of the premises to be true. And finally, what I'm supposed to do is, like, in those rows, I need to check that the conclusion is also true. And you would notice that in the first one, I have true, and the conclusion is true. So this would be good for a valid argument. However, since the second row has true and true, but the conclusion is false, this is not okay in a valid argument. In a valid argument, all of the rows where the premises are true, the conclusion would need to be true as well. So that means in these, because the two premises are true and the conclusion ended up false, then that one row makes the whole argument invalid. So this argument is invalid. So my final comment is, this argument that has two premises and the conclusion is an invalid argument. Invalid argument. Okay. So I'm almost done. I think I just have one more example. So the last example is, in a similar way, another form to determine if an argument is valid or invalid, you could do what we call an Euler diagram. And again, within your formulas, you already have, within your formulas for the test, you should ask your instructor, like, hey, can I have the formulas to for all of the different types of Euler diagrams. And so when an Euler diagram starts with all, basically for this one we have frogs, and then we have poetical. So the first premise, you will represent this by doing two circles, one inside of another one. So the smaller, by saying all frogs are poetical, then that means that frogs, the population of frogs, is inside the population of poets, or poetical. So this premise number one, all frogs are poetical, is represented by drawing two circles with the circle of frogs inside of the circle of poetical. This is very similar to kind of like saying that a state is part of a country, like saying Texas is part of the US. Well, it's not the only one. There's also other states such as Arizona, Florida. So, but we're only in this case, we're only talking about frogs, so we have only one circle that represents frogs and a larger one that has everything that is poetical. Okay, then we have the next premise says Kermit is a frog. Well, to represent that, Kermit, that would be like a dot inside. So I represent Kermit by putting a dot inside of the frogs. And then I look at the conclusion, therefore Kermit is poetical. Well, this is a valid argument, because by putting the dot inside the frogs, then since the frogs are contained inside of the poetical, then automatically it implies that Kermit is poetical as well. So this is a valid argument, since using the Euler diagrams, you can draw that same conclusion by putting Kermit inside the frogs that's already contained inside of the population of poetical. A conclusion that would be wrong is if my conclusion was, if instead of this, it said, instead of premise 2, if it said Kermit is poetical, And therefore, the conclusion would be, therefore, Kermit is a frog. This would be wrong because when you get to when you get to the second premise, you would put Kermit inside poetical. Well, you could put it inside the frogs, but you could also put it outside. And if you put it outside, it would classify as something that is poetical, but it doesn't make it automatically a frog. So basically, that's kind of like the idea that as you put in these circles, usually the conclusion is correct when the diagram, the circles support the conclusion. So since the conclusion is Kermit is poetic, it's a frog. Since the conclusion is Kermit is poetical, that's something that you can conclude from the diagram as well. Okay, well, I'm gonna stop here. Thank you for joining me, and I hope you have a good weekend.
Thank you so much, Mr. Tintos, for presenting today. Thank you all for coming and being such a wonderful audience, and we definitely hope to see you again soon. So join us next week, and if you look at the flyer we're sharing with you right now, you'll see that for Math 1332, we'll be covering numeration systems, place value systems, and base systems. And for Math 2412, vectors, and hope to see you soon. So hope